Welcome, I am Mrs. Tonioli, and today we are going to be doing Expressions Lesson 3, Evaluating Expressions. Our learning target today is to use the order of operations, including those with exponents, to evaluate expressions when given specific variable values. So we're going to be given a value for the variable, we're going to substitute that in, and then use our order of operations to find the value of that expression. Before we do that, though, we need to cover a couple of important vocabulary terms that we use all the time when we are talking about expressions. So right here in the middle, we have our expression of 5x minus 3. The first vocabulary term that we are going to talk about is this one right here. What are the terms? If you think of an expression like a sentence, the terms are the words in each sentence. And just like we separate words with spaces, in a number sentence, we separate terms with an addition or a subtraction symbol. So in this expression, we have two terms. 5x would be a term, and 3 would be a term separated by the subtraction symbol. 5x is together. It's stuck together. Those are partners, and so they stay together. They are one term together by themselves. So that is what a term is. Let's look at another vocabulary word. We're going to look at this one right here, a constant. What is a constant? Constants are terms that never change. So this 3 is the constant in this expression. 3 will always be worth 3. This term, the value of it will change depending on what the value of x is. So it is not considered constant. Only the 3 is considered a constant. All right, the next vocabulary word we're going to look at is this one right here. This one shouldn't be new. A variable. A variable is the opposite of a constant. Variable means it changes, and so variables are letters that stand for different values. So in this expression, our variable is x. X can be whatever I decide I want it to be. I can put any value in for x that I want. It can change, therefore it is the variable. And the last vocabulary word that we are going to spend time with is this one right here. This one seems to be the hardest. It is a coefficient. The coefficient is only in terms that are multiplication terms where you have a constant right next to the variable. The coefficient is that constant that goes in front of the variable. We always write the coefficient first. We would not write x5. That would not be how we would write it mathematically. And so that constant, which is 5, would go right in front of the variable, and we call it the coefficient. So those are the 4 words that we're going to practice here. Identifying. So we have this expression, 6m minus 2n plus 7, and we are going to identify those 4 different parts of our expression. I'm going to start with the terms because I think that is the easiest to identify right at first. Remember, the terms are like the words in our number sentence, separated by addition and subtraction symbols. So we have a term right here, we have a term right here, and we have a term right here. So I have 3 terms in this expression. And so down here in my box, I'm going to list my terms. I have 6m, I have 2n, and I have 7. I'm going to separate them with a comma so that it's easy to tell what those 3 different terms are. Next, we're going to identify the variable in this, or variables in this expression. Variables are letters that stand for numbers that I can put any number into. So I have m and I have n. Those are my 2 variables. So I'm going to list those down here under my variable heading. Now I'm going to identify the constants. So the constants are the ones that never change. Their value will always be the same. So that number 7 right there will always equal 7. Its value never changes. So it is a constant. And the coefficient, that's our last one, that is that variable that constant right in front of your variable. It's the variable's buddy right there. They're kind of stuck together. So we have two of those in this expression. We have 6 and 2 as our coefficients. Okay, let's try another one right here with this expression, 4n squared minus 5y plus 7. Let's go ahead and identify those terms first, which are the separate words in our sentence divided by the addition and subtraction symbols. So there would be a term, and there would be a term, and there would be a term. So I have 3 terms in this expression, and I'm going to list them in this box right here. I have 4n to the second power, and I have 5y, and I have 7. Oh, oops, those are all written as exponents. We don't want that. Let's go ahead and take that off of there. There we go. Oh, 5y. Okay, next I'm going to identify my variables. Those are my letters that stand for numbers that I can put any number in. So I have a variable right there. N is a variable and y is a variable. So I'm going to put those in my variable column right there. Okay, I'm going to next look at the constants. The constants are the values, the terms that don't ever change. They stay the same. So this 7 out here, that is the constant in my expression. Its value will never change. It will always be worth 7. And the last thing we're going to look for are the coefficients. So a coefficient is this constant that sits right in front of the variable. It's kind of attached to it. It's its buddy. So we have 2 coefficients. We have 4 and we have 5. So those would be the different parts of our expression: coefficients, variables, terms, and constants. Go ahead and pause the video and see if you can fill out this chart on your own, and then push play and check your answers and see how you did. Okay, so first of all, I'm going to identify the terms, which are those separate word parts, if we're looking at it as a sentence, which are separated by addition and subtraction symbols. So this one has actually 4 terms in it. So as I type in that box, we should have 5x squared as the first term. And then we have 2y as a term, and 9xy as a term, and 4 are my terms there. Okay, let's see if we could identify the variables. Variables are the letters that stand for unknown numbers. So I have an x and a y, and I have x and y in different terms, but x will be the same value no matter which term it's in if it's in the same expression. So will y. So when I type in my variables, I really only need to type in x and y once. I don't have to write it in twice because x always will have the same value within the same expression. Okay, let's see about identifying a constant. So constants are the terms that never change. So 4 is my only constant in this expression. 4 is always worth 4, and that value is never going to change. And now let's find our coefficients. Coefficients are attached to those variables. They're buddies. They're right next door to them. So 5 is attached to the x squared, 2 is attached to the y, and 9 is attached to the xy. So we actually have 3 coefficients in this expression. So we would fill in 5, 2, and 9. So check your answers and see how you did. If you made a mistake, kind of look at it closely and figure out what you did wrong. All right, let's move on now to evaluating our expressions when given a certain value for a variable. So we have a table here, and we have all of our x values. So x is a variable, which means we can put any number in for it that we want. So we have a list of different numbers that we are going to put in for x. And then our y is what the value of that expression would be. So out here to the side, I'm going to substitute, make sure we can see here. I'm going to substitute 5 in for x, which means I would have 9 times 5 plus 6. Wow, that did something really weird. So I would have 9. We'll try it a different way, I guess. 9 times 5 plus 6. So I'm going to multiply before I add because that's what my order of operations are. So 9 times 5 is 45, plus 6 would be 51. So I would type in 51 because when x is 5, that expression is worth 51. I'm going to do the same thing for the rest of these numbers. I'm going to substitute 1 in for x. So 1 times 9 would be 9, plus 6 would be 15. So I'm going to put 15 in that box right there. I'm going to do the same thing for 4. I'm going to substitute 4 in here. Remember, this does mean 9 multiplied by x. It doesn't mean 9 added to x. So if I put a 4 in for x, I'm not going to have 94. It means 9 times 4. So 9 times 4 is 36, plus 6 is 42. And then if I put 3 in, 9 times 3 is 27, plus 6 is 33. And if I put a 7 in, 9 times 7 is 63, plus 6 is 69. So I have now evaluated that expression for all of those different values of x. Okay, pause the video and fill out this table on your own, and then go ahead and check your answers with mine. Okay, if I put 3 in for x, this means 6 times x minus 2. So I would have 6 times 3 minus 2. And then I would use the order of operations. So I would do 6 times 3 first, which is 18, and subtract 2, which is 16. If I put 8 in for x, I would have 6 times 8 minus 2. So 6 times 8 is 48. Minus 2 is 46. If I put a 6 in, I would have 6 times 6 minus 2. 6 times 6 is 36, and 36 minus 2 is 34. If I put 7 in for x, I would have 6 times 7 minus 2. So 42 minus 2 is equal to 40. And if I put 5 in for x, I would have 6 times 5 minus 2. So 30 minus 2 would be 28. So check your answers, and hopefully you got those all correct. All right, this one's a little bit trickier because we have a fraction. And so we have to remember what we have already learned about fraction operations and how to multiply by fractions. So here are my values of x that I'm going to substitute in, and then I am going to solve it the same way that I would before. Make sure we follow the order of operations and solve. So 1/5 times 6 plus 5. All right, so 1/5 times 6 gives me 6/5. I'm going to do my little drawing tool here so that I can write these fractions a little bit easier. So 1/5 times 6, I would put that over 1, gives me 6/5 plus 5. So I can do one of two things here. I can find a common denominator because I can't add these fractions until I have a common denominator, or I can change this into a mixed number and then add my whole numbers together and then my fractions. So 6/5 is 1 and 1/5 plus 5. So now I can just add those whole numbers together and I get 6 and 1/5. So when we put 6 in for x, we get 6 and 1/5 as our answer. Let's see, try to delete these here. Okay, so let's try this with 4. If I put 4 in for x. If I put 4 in for x, I'm going to have 1/5 times 4 plus 5. That gives me 4/5 plus 5. I can add those together pretty easily. That's just 5 and 4/5. So if I put x in there as 4, then I get 5 and 4/5 as my answer. All right. Go ahead and see if you can do the next one on your own and then check it with mine. Okay, so we substitute 3 in for x, so I have 1/5 times 3 plus 5. That gives me 3/5 plus 5. And that would be 5 and 3/5. So when x equals 3, my expression is equal to 5 and 3/5. Okay, let's put our 7 in there and see what we can get. So with a 7 in there, I have 1/5 times 7 plus 5. And that gives me 7/5 plus 5. Now I can find a common denominator, or I'm going to move my work up here. Sorry, I have a little bit more space up there. I can change that 7/5 into a mixed number. So I have 1 and 2/5 plus the 5. And then that's easy to add because I can just add my whole numbers and then my fractions. So I have 6 and 2/5. So when x equals 7, my expression equals 6 and 2/5. Okay, for the last one, let's put 2 into our expression and see what we get. So I have 1/5 times 2 plus 5. So I have 2/5 plus 5. So I just need, there's no whole number here to add, so I just have 5 and 2/5. All right, so that wasn't too bad, even with a fraction. We just needed to remember how to multiply our fractions there. All right, let's go ahead and try this one. It's only a little trickier because we have two different variables in our expression. We have a d and we have a t, but we're just going to go ahead and substitute 10 in for d, and I'm going to substitute 5 in for t. So if I do that and I rewrite my expression, I have 10 plus 12 times 4 minus 5. Now I need to remember to follow my order of operations here. So I'm going to need to multiply before I add or subtract. So I have 10 plus 12 times 4 is 48 minus 5. Now I'm going to add and subtract whichever comes first. So I have 58 minus 5. And then 58 minus 5 is equal to 53. So my final answer, this expression, would be 53. All right, now we're going to add an exponent in here, so it makes it slightly harder. Again, I have two variables, so I'm going to substitute 7 in for the k, and I'm going to substitute 2 in for the q. Now this squared out here means I need to do everything that's inside the parentheses and then square it. So I'm going to complete all of that before I square it. So I'm going to substitute my numbers in. So I have 6 times 7 minus 8 times 2. And all of that is still inside some parentheses. And then I'm going to square it after I figure out what all of that is equal to. So 6 times 7 is 42, and 8 times 2 is 16. So 42 minus 16 is going to be 26. And then I'm going to need to square that. So I'm going to have 26. What in the world? So I'm going to have 26 squared. And find out what that equals. That means 26 times 26. So let's see if we can pull up my calculator over here. And it looks like that is going to equal 676, not squared. 676, right there. So our expression will equal 676 when k is 7 and q is 2. All right, this one is written as a fraction. It has technically the fraction is division, but because of the way it's written, we do the numerator and then we do the denominator. So when we substitute this in, we're going to do 5 minus 4, and then we're going to divide that by 3. So 5 minus 4 is 1, and then divided by 3 is just 1/3. So our expression would equal 1/3. Okay, turn the video on pause and try this one yourself and then check your answer. Okay, we're going to substitute 3 in for A and we're going to substitute 18 in for B. So as we retype those here, we have 3 minus 3 times 12 divided by my dividing symbol in there. Doesn't want to do it. There we go. Divided by 18. All right, so we're going to follow our order of operations. So we're going to have to multiply and divide from left to right, whichever one comes first. So that means I don't do anything with this 3 to start with. So then I have 3 minus 36 divided by 18. And so now I'm going to do the division. So 36 divided by 18 is 2. So I have 3 minus 2, and that equals 1. So that expression equals 1 when the A is 3 and B is 18. Okay, try this one on your own and then go ahead and check it. Remember that this squared is outside of the parentheses, so it means we want to do everything within the parentheses first, and then we're going to square it. So we're just going to substitute 8 in for the W. And so our new expression would be 7 plus 3 times 8. And then we would square that in the end. So I have 3 times 8 first. So I have 3 times 8 equals 24. And then 24 plus 7 is 31. So I have 31 squared, which means 31 times 31. So I would go ahead and work that out. And I would get 961. So my expression would be equal to 961. Okay, this one adds a little bit of decimal operations into this. So we have to remember what we've already learned in number systems in dealing with our decimals. But otherwise, it's exactly the same. We're going to substitute that 12 in for D, and we're going to substitute this 2 in for X. And then we're going to follow our order of operations and we're going to solve. So I have 4 2/10 times 12 minus 7 times 2 plus 3. So 4 2/10 times 12 is what we are going to be doing first. And if we do that correctly, we get 50 4/10. and then minus 7 times 2 is 14, and then add 3. So 50 and 4/10 minus 14 is 36 and 4/10 plus 3, and that would equal 29 and 4/10. So 29 and 4/10 would be the value of our expression. All right, this one looks pretty similar, except that we are using some fraction values. So h is equal to 1/3, so I'm going to substitute 1/3 there. And p is equal to 7/12, so I'm going to substitute that in right there. So I would have 1/3 plus 7/12 times 4. So I would need to multiply first. So I would have 1/3 plus 28/12. All right, I think I'm going to find my common denominator first so that I can add these two together. So 1/3, if I find that as a common with a denominator of 12, I would have 4/12 plus 28/12, and that would give me 32/12. Now I can't leave that. I need to simplify it. So that means 32 divided by 12. So 12 goes into 32 twice. That's 24. And there would be 8 left over. So 2 and 8/12, which is still not simplest form because I can divide both 8 and 12 by 4. So I'd have 2 and 2/3. So the value of my expression would be 2 and 2/3. All right, hope this helps, and good luck on your assignment.